Hello, we discussed question number 14 from the chapter sequence and series and from your miscellaneous exercise. So, here to mark let S be the sum and P be the product and R be the sum of reciprocals of n terms in a GP. So, main to mark we have n terms in a GP. So, prove that this P square into R to the power n equal to S to the power n. So my n terms in a GP ase ami dhori loisu let. So we consider let the GP be a ar square ar cube goes to ar to the power n minus 1. So how many terms we have? N terms. So this is our n terms of a GP. Ar, first term, second term, third term, fourth term. When we have fourth term, then ar cube, and this is our nth term, ar to the power n minus 1. So according to the question to mark key this, according to the question, S is the sum of what? N terms in a GP. Capital S is equal to what? Sum of the n terms. That means a plus ar square goes to how much? Ar to the power n minus 1. This is the sum of n terms of the GP. So we know sum of n terms of a GP formula. What is our first term here? A. And what is our common ratio? R. AR by A is R. AR square by AR is again R. So what is our common ratio is R. So we have R to the power n minus 1 whole thing divided by R minus 1. So S we have this. So put it as equation number 1. Again, what we have? P be the product. P be the product of this n terms. So again, what we have? P equal to a into ar square goes to it goes to what? Ar to the power n minus 1. So in first term we have a, second term we have a, third term also a goes to what? A. So how many terms we have? N terms, and in each term we have a. Each term we have a. So how many number of times a multiplies? N times. So a to the power n. We are left with r. ঠিক আছে? So তোমাৰ ইয়াত তোমাৰ r to the power 1, here r to the power square. So same base, so since same base, our power will get added, goes to what? n minus 1. ঠিক আছে? an 1 plus 2 plus 3. So this is the what? Sum of first n minus 1 terms. Sum of n minus 1 terms. So we have a formula we have studied already, that sum of first n terms. What is the sum of n terms? 1 plus 2 plus 3. Sum of the first n natural numbers. Sum of the first n natural number we have n into n plus 1 by 2. ঠিক আছে? So when our last term is n, our formula is n into n plus 1 divided by 2. So therefore when we'll have this 1 plus 2 plus 3 goes to n loke najae mane tumar n minus 1 loke jabo. When it will goes to n minus 1, then we'll have in place of n we'll have n minus 1. In place of n we'll have n minus 1. n minus 1 plus 1 divided by 2. So tomar minus 1 plus 1 so we'll be left with n minus 1 into n by 2. So this is the what? Sum of sum of first n minus 1 natural number. So eto ami formula jano 1 plus 2 plus 3 goes to what n. Tama formula hai ki n into n plus 1 by 2. Yata amar ki hoise 1 plus 2 plus 3 plus 4 plus ko loke goise tama n minus 1 loke goise. So jete n minus 1 loke jabo amar ki hobo n minus 1 into n minus 1 plus 1 by 2. ঠিক আছে, তো এটা আমার হবে n minus 1 into n by 2. So in place of this, what will you like this? 1 upper kole goes to n minus 1 okay goes. So using this formula, we put here n minus 1 into n by 2 r to the power n minus 1 by 2. So all of the equal dhunake likhi disu a to the power n r to the power n into n minus 1 by 2. Take it as equation number 2. So this is your p. And third, what we are given? Third, we are given that r be the sum of the reciprocals of the n terms. R is the what? Sum of the reciprocal. First term, what we have? First term we have a. So what is the reciprocal of a? 1 by a. Sum of the reciprocal, so 1 by a plus 1 by ar, because second term is ar. ঠিক আছে, so reciprocal of second term 1 by ar, reciprocal of third term ar square 1 by ar square, so plus 1 by ar square goes to what? 1 by a r to the power n minus 1. 1 by a r to the power n minus 1. Ita tumar ki kora para, ita tumi LCM lo para, you can take LCM. So what we can take LCM? This. So taking LCM, take LCM this a into r to the power n minus 1. So taking this LCM, will be left it here we have a, where we have a, so our a will be not left, so will be left with r to the power n minus 1 into 1 plus ar r to the power n minus 2 plus ar square r to the power n minus cube. It goes on, we will left with 1. So now what we do? We write 1 by a into r to the power n minus 1 as it is, and bracket we write this numerator as 1 plus 2 plus goes to not this 2, this is not 2, goes to what? R to the power n minus 3 plus r to the power n minus 2 r to the power n minus 1. Now this is a GP series. This is a what? GP series with first term a and common ratio r. With first term a and common ratio r. This is our common ratio r, because r to the power n minus 1 divided by r to the power n minus 2, you will have what? Common ratio r. So how we write the sum of a GP series? So this is GP series. So we write the sum of a GP series as to the power n minus 1. First term what we have? 1. So we write 1 into r to the power n minus 1 whole thing divided by r minus 1. Now this is a GP series. This series is exactly same as this. This is exactly same as this, but in here we have a plus ar plus ar square goes to what? Ar to the power n minus 1. But here we have, in place of a we have 1 plus we will have r plus r square goes to what? R to the power n minus 3 plus r to the power n minus 2 r to the power n minus 1. So this is similar to this, but in place of a we have 1. Every a we have 1. Jiman a ase tat ami 1 put kori disu mane. So yat formula to thait 1 or thait tomar a thait tomar 1 hobo. So take it as equation number 3. Now what we are said, you have to prove that p square r to the power n equal to s to the power n. p square r to the power n equal to s to the power n. So take your left hand side. Now take your left hand side. P square r to the power n. So what is your p square? What was your p square? Check it out. Your p is this a to the power n into r to the power n into n minus 1 by 2. So a to the power n into r to the power n into n minus 1 by 2 whole square we have. So whole square. Next we have r to the power n. So we have put the value of r n to the power n minus 1 whole thing divided by we have a n into r to the power n into n minus 1 into r of minus 1 and the whole thing to the power we have n. ठीक है. Now multiply product a to the power 2n r to the power 2n n minus 1 by 2 into r to the power n minus 1 to the power n a to the power n r to the power n into n minus 1 into r minus 1 to the power n. So check it if we can do some calculations. A to the power 2n r to the power we will be left with n into n minus 1 into r to the power n minus 1 whole to the power n. Next we have this a to the power n, then this a to the power n we can cancel it. R to the power n into n minus 1, this will get cancelled. R minus 1 to the power n. So we'll be left with yet a to the power n, it will cancel the power. So we'll be left with, here we have twice n, so we'll be left with 1 a to the power n into r to the power n minus 1 thing divided by n, r minus 1 to the power n. So we can write in this way, a into r to the power n minus 1 divided by r minus 1 whole n, because here n, here n, here n. So we can write this. Now this is the formula of s by 1 equal to your right hand side. Proved. So next we see question number 17. Here to mark it as if A, B, C and D are in GP, prove that these are in JP. So given likhi loba, given A, B, C and D are in GP. A, B, C and D are in GP. Therefore tomorrow ki hobo? My first in the term loso. If A, B, C, D are in GP, then A, B, C are also in GP. A, B, C are also in GP. So you can write. Prothom tinta termo tomar GP thakibo. Since A, B, C, D are all four are in GP, so A, B, C are also in GP. Are also in GP. Therefore, how we can write? Second term by first term, B by A equal to third term by second term. So from here what we'll get? B square equal to, yes, we put that as equation number 1. Again, B, C, D are also in GP. Since A, B, C, D all the four are in GP, so we can write B, C, D are also in GP. Are also in GP. Therefore, how we can write this? C by B equal to D by C. C by B equal to D by C. c square equal to c square equal to bd. C square equal to bd. So from 1 and 2 you can write ki palu ami b square equal to ac palu aru c square equal to db palu. Also we can write, also since a b c d are in gp, we can write second term by first term equal to third term by second term equal to fourth term by third term. ঠিক আছে আৰু আমি এই দুটা ফ্ৰেকশন লৈ ba by cb পাই পেলাই আমি এটা পালো ba by c পাই পেলাই b স্কয়াৰ ইকুৱেল টু ac পালো cb আৰু dc এই দুটা ফ্ৰেকশন লৈ পেলাই আমি c স্কয়াৰ db পালো এতিয়া আমি ba আৰু b by a equal to d by c লওঁ b by a equal to d by c ললে কি হ'ব b by a equal to d by c যদি লওঁ তেতিয়া আমাৰ আহিব bc equal to ad. Take it as equation number 3. Take it as equation number 3. So it is not proof koribok dise ki you are asked to prove what? You are asked to prove these three terms are in gp. To show a to the power n plus b to the power n comma b to the power n plus c to the power n comma c to the power n plus d to the power n in gp. That is to show this is our second term, this is our first term, and this is our third term. So what we must have b to the power n by c plus c to n second term by first term must be equal to third term by second term, so cross multiply it. So cross multiplying it will get b to the power n plus c to the power n whole square equal to c to the power n plus d to the power n into a to the power n plus b to the power n. So this, so we have to show this, we have to show that these three terms are in gp. That means to show this. If we can show this equation, then we are done. If we can show this equation, that means what? These three terms are in gp. So we are done with the proof. So we'll take our left hand side first. So now we'll take left hand side, we'll prove this, isn't it? We'll prove this, that means this is equal to this. So we'll take our left hand side first. So what is our left hand side? b to the power n plus c to the power n whole square. So break it in a formula, b to n plus b to the power n into c to the power n plus c to n. ঠিক আছে, এটা b we can write in this way plus c square n. So in place of b square, from our we have to have got b square equal to ac, isn't it? In place of b square we can write ac plus b to the power n c to the power n, and in place of c square we can write bd to the power n. So by 1 and 2, so next break it, a to the power n c to the power n plus b to the power n c to the power n. Here we have 2 b and c, b to the power n c, so one we write in this way plus b to the power n c to the power n plus b to the power n and d to the power n. So from here we take c to the power n common, a to the power n will be left with b to the power n. Next again from here we take b to the power n common, will be left with Before taking common, we have to do one thing, that we'll take a to the power n, c to the power n, b to the power n, c to the power n plus bc whole to the power n. We write this bc bn to the power cn as bc whole to the power n bn dn. So in place of bc, we write this. Bc means what? We have ad. So in place of bc we write ad a n c to the power n plus b to the power n c to the power n. In place of bc we write ad to the power n plus b to the power n d to the power n, from which we have used from equation 3. So a to the power n, c to the power n, b to the power n, c to the power n, a to the power, so from d to the power n plus b to the power n, d to the power n. So from here we take c to the power n common, a to the power n plus b to the power n plus d to the power n plus a to the power n, b to the power n. So this comes common, a to the power n plus b to the power n into c n d n. So this is actually equal to your right hand side. This is actually equal to your right hand side, this. So if this is equal, if bn plus c to the power n whole square, if this is equal, that means what we can say? That means we can say a to the power n plus b to the power n comma b to the power n plus c to the power n comma c to the power n plus d to the power n are in what? Are in GP. So we are done. So next we are taking question number 21. So here we are asked to find a sum. So this type of questions are very common, so practice it well. So question number 1 is given, so 5 plus 55 plus 555. It goes on. So fourth term will be what? 5555. First term 15, second term 25, third term 35, and it goes on like this. So second question we have what? First term 0.6 plus second term 0.66, third term we have 0.666, and it goes on in this way. So we'll do this question, we'll solve this question, and this question is your homework. Try by yourself. 0.6 plus 0.66 plus 0.666. This type of question we have a particular procedure. So similar same questions may not come in your exam, but so learn the procedure how to do it. So if this type of series comes, this is neither GP series nor AP series. This series is neither GP nor AP. Okay, so to tackle with this type of series, what we'll do first, we'll take out common. 0.6 will take out common. So first term, sorry, we'll take 6 common. So first term will be left with 0.1. So we can verify it. 6 into 0.1, what will have? 0.6. Plus again when we'll take 6 common out, so we'll be left with 0.11. So from the third term we'll be left with 0.111, and it will go on in this way. It will go on in this way. Okay. Now what we'll do, we are in the question we are given find a sum up to n terms. We have to check up till which term we have to we are asked to find a sum. Find a sum up to n terms. So find a sum up to n terms. So we take let Sn equal to 0.6 plus 0.66 plus 0.6666, and it goes on. How many terms we have said? N terms. So we are taking it Sn. So 2 n terms. Okay, 2 n terms. So now we'll do this step. We'll take the 6 common. 0.1 plus 0.11 plus 0.111, goes on. How many terms? N terms. 2 n terms. Okay, now what we'll do, we'll multiply 9. We'll divide 9 and multiply 9, so that it gets balanced. Multiply 9, divide 9, so that it gets balanced. Next we'll take multiply this 9 to each terms. We'll be left with 0.9 plus 0.99 plus 0.999, how many terms? N terms. N terms. So 6 by 9, 0.9 can be written as 10 minus 1. No, 10 minus 0.9 can be written as not 10 minus 1, 1 minus 0.1. 0.9 can be written as what? 1 minus 0.1. Clear? 1 minus 0.1. Similarly, 0.99 can be written as 1 minus 0.01. ठीक है सर, 0.99 can be written as 1 minus 0.01. So 0.999 can be written as 1 minus 0.001. ठीक है सर, it goes to how many terms? Plus 2 n terms. Now what we do? This 0.11 minus 0.1 can be written as 1 by 10 plus 1 minus 0.01 can be written as 1 by 10 square plus 1 minus 0.001 1 by 10 cube plus 2n terms. So next what we do? We take all the 1 together. We write all the 1 together. Up till how many terms we have? N terms. ठीक है सर, we write all the 1 together. So 1 plus 1 plus 1 plus it will goes on to how many terms? N terms. To n term minus, and we write all the these terms. We will be left with 1 by 10 minus we are taking common, plus then we'll have plus 1 by 10 plus 1 by 10 square. 1 by 10 cube goes to what? 2n terms. 2n terms. So 6 by n. So here we have 1 plus 1 plus 1 plus how many terms? N terms. So every term we have 1. How many terms? N terms. N times মানে তোমার 1 1 add হয়েছে। 1 plus 1 plus 1 plus 1 plus কেইবাৰ হয়েছে তোমার? N times. So তোমার n into 1 minus 1 by 10 plus first term তোমার first term we have 1 by 10 to the power 1 plus 1 by 10 to the power square. Third term we have 1 by 10 to the power cube goes to plus n terms 1 by 10 to the power n. Third term যদি তোমার 10 to the power 3 হয়, obviously তোমার nth টার্মত কি হ'ব? n terms কৈছে 2n terms মানে তোমার nth টার্মত হ'ব 1 by 10 to the power n. এতিয়া তোমাৰ হ'ব 6 by 9 n into 1 n. এতিয়া 1 by 10 to common লৈ দিয়া। 1 by 10 common লৈ তোমাৰ আহিব 1 minus 1 plus sorry 1 plus 1 by 10 common লৈ ইয়াত 1 থাকিব, ইয়াত 1 by 10 common হ'ব, 1 by 10 থাকিব, 1 by 10 square থাকিব তোমাৰ গৈ আছে ক'লৈকে 1 by 10 ইয়াত 1 by 10 এটা common লৈ 10⁹9 n আছে, so n minus 1 হৈ যাব। এটা 1 by 10 common লৈ এটা 1 by 10 common লৈ তোমাৰ power n আছিলে, 1 by 10 এটা common লৈ n minus 1 হৈ যাব power. So now this is a GP series. This is a what? GP series. This is a GP series with first term what? With first term a equal to 1. First term we have 1. Common ratio we have 1 by 10. Why? 1 by 10 divided by 1 is 1 by 10. 1 by 10 square. 1 by 10 square divided by 1 by 10 is again 1 by 10. So common ratio among 1 by 10 which is less than 1. Common ratio we have 1 by 10 which is less than 1. So how we have common ratio 1 by 10? Check it here. First term কি আছে, second term কি আছে 1 by 10. First term আছে তোমাৰ 1, so 1 by 10 হ'ব। Third term কি আছে 1 by 10 square, 1 by 10 square divided by 1 by 10 1 by 10 so tomar this 10 square or 10 cancel hobo 1 by 10 hobo so common ratio tomar 1 by 10 hobo second term divided by first term 1 by 10 third term so tomar 1 by 10 square 1 by 10 square divided by 1 by 10 third term divided by second term 1 by 10 square divided by 1 by 10 1 by 10 square divided by 1 by 10 to 1 by 10 hobo so common ratio tomar 1 by 10 hobo which is less than 1 so amar sum of the gp sum of n terms of a gp sum of n terms of a gp whose common ratio is less than 1 hetu formula use kori 1 by 10 so this is gp series for first term case 1 ase so 1 into 1 minus 0 tomar common ratio 1 by 10 which is less than 1 so we'll have the formula 1 minus r to the power n r to the power n r case at 1 by 10 to the power n minus 1 by 10 so this is our answer so okkoman dekhibole hondor koi dia 6 by 9 n minus this 1 minus 1 by 10 to 9 by 10 hobo so 9 by 10 so tomar 10 upole jaboge 10 by 9 hoy jabo this here will be left with 9 by 10 so reciprocal hogale 10 by 9 hobo aur tomar khini 1 minus 1 by 10 to the power n so 6 by 9 answer is 6 by 9 10 cancel jabo 1 by 9 so this is your required answer so this is the sum of the series this is the sum of the series this so apply the same procedure do this for this series ya prothome 5 common loba let sn loba ekhini likhibo na lage direct ebar koriba let sn equal to loba ya tomar 5 plus double 55 plus 555 hobo ঠিক আছে এনেকে 5 common loba 5 common loa pasot tomar 9 divide koriba multiply koriba but ya tomar 0.1 nahe 1 ahibo 1 plus 11 plus 111 so try it if there is any problem ask for help ঠিক আছে thank you